The answer for sample problem 20.8, kind of finding the temperature at which a reaction becomes spontaneous, can be really straightforward if you're given all the information. I'm going to work through this problem a little bit more in detail just to kind of show you how the problem could be made a little bit more challenging, starting from even just looking at the chemical reaction here. They don't give us the chemical reaction. It's actually within the textbook, and that's where they expect you to get values from the text. But I'm going to show you how you could solve this problem if you didn't have values that you got from the text. So as an example here, let's write down what the chemical equation is. So here is copper oxide, copper 1 oxide, and reacting with solid copper, and this is actually going to be the graphite form, not the diamond form. That's going to make 2 moles of copper solid plus some carbon monoxide gas. So that's the chemical reaction for the process. And they say at 25 degrees C, the reaction is non-spontaneous. So delta G is going to be equal to positive 8.9 kilojoules. And so we'd like to know what temperature the reaction will become spontaneous. So what we're going to actually do, it tells you that we can get the delta H and delta S values from the text, but I'm going to show you how this problem could be made a little bit more challenging and how, for example, I might do a problem like this on the test if you actually had to use Appendix B to go ahead and calculate your delta H and delta S values. So for example, we could calculate delta H using delta HF values, and we could use S values to calculate our entropy. So again, the units for this are going to be kilojoules per mole. This is going to be joules per mole Kelvin. And I'm just going to fill in the values that I get from Appendix B. Remember, anything that's in its elemental form will have a delta HF of 0. Okay, so if we go ahead and we do our delta H of reaction, again, we can do products minus reactants that will give us a value of the enthalpy of 58.1, positive 58.1 kilojoules. Do the same thing for delta S. And for our entropy, we get a positive 164.9 joules per Kelvin. And as we look here, if we cheated, we could actually see that those match the values from the text. One other thing that I want to kind of show you is if we take delta G equals delta H minus T delta S, we've got 58.1 kilojoules minus 298 Kelvin times 1649 kilojoules per Kelvin. That ends up being 8.93 positive kilojoules, which is again what they already gave us there. So they were assuming, get this value from the text, get this value from the text. I showed you that you don't have to get them from the text. You can calculate them like we've calculated things previously. And that's how I could make a problem like this a little bit more challenging on the test. Just confirm for you that those values are indeed the right values because they give us back the reported delta G value. All right, but now what we're really ready to do is say, you know what, let's find the pivot point. Okay, and the pivot point is when delta G equals 0. So what we can do is we can set delta G equal to 0, and we can solve for T. So we've got T delta S equals delta H. So T equals delta H over delta S, and we can put in the terms that we just had. Again, I'm going to convert, in this case, my delta H to joules, but you could do this either way. 58,100 joules over 164.9 joules per Kelvin. Again, when we've got in the denominator of the denominator units of Kelvin, that will give us units of Kelvin overall. We get 352 Kelvin. Happens to be 79 degrees C. So that, again, is the pivot point for this reaction. Another qualitative question that I could ask you, if this is what the pivot point is, I could say, does it become more or less spontaneous as we increase temperature, right? You could put an increased temperature into this equation, or we could look at entropy and say that entropy is helping us. So this reaction will actually become more spontaneous as we go above 79. So again, just because you define and find what the pivot point is, you still have to do a little bit more thinking to realize, well, does my reaction become more spontaneous or less spontaneous as I go above this or below this?